Testing audio. Okay. Right. All right. Good evening, all. We'll start. Can you confirm whether I'm clearly audible and visible? It's working fine, right? Is it? Yeah, it's working fine, right? Okay, it seems it's working fine. Right. So we'll start. Now today we are in the day 19. We are the day 19 of S2A. And now in S2A discussions, so far I have been discussing about the past papers, no? Right? I have been discussing the past paper questions, MCQs, structured essays, so likewise past papers. And today, now since the support seminar paper is also out, I thought of taking this session, S2A session, to discuss the support seminar paper this year. And for all subjects, now support seminar papers are out, right? For all our science subjects, except ICD, right? Except ICD for all other subjects, right? For main subjects, support seminar papers are out, right? Then now I'll be discussing the physics one. So if you haven't discussed the other subjects yet, so you better get those papers and try those papers, because when it comes to support seminar questions, there are some kind of a importance, a value, right, before you are going to the exam to practice as practice questions, right? Support seminar papers has not been like streamlinedly continuous over the past years, right? 2013 to 2019 is there, then again 2019 to 2013 to 16, then there's no support seminars for 17 and 18, then it was 19 again, and after 19, now this time we have got, so likewise, sometimes it discontinues. I don't know what the reason, but for some reason it discontinues, but this time all papers are out. So about other subjects also, right, you can try those support seminar questions and see. And about the support seminar paper, that is very much similar to the paper you are going to get at the exam in terms of difficulty. In terms of the difficulty level, that is very much similar. In terms of the difficulty level, that is almost same. Very much similar, right? Okay, then to download the support seminar paper, if you haven't got it yet, what you can do is you can get it from my Telegram channel. But these days, if you are trying to create a Telegram account as a new account, I think without doing a payment or a subscription, you can't create an account, I think, because some students inform that that is not working or something, right? So in that case, we have to check for an option, because for WhatsApp channels, file uploads are not allowed. Files means PDF uploads. PDF uploads are not allowed in WhatsApp channels. So I'm still using Telegram, and if your account is an old one, I don't think you have an issue. But for new ones, I think something is happening. Let's see. Right. Okay. Now, if you haven't got the paper, one option is you can visit my Telegram channel and get the paper there. But if not, you can just Google it and download as well, right? So somehow first you have to get the paper, right? So today I'm going to start the MCQs of the support seminar paper, right? Then without further ado, let's go to the discussion, right? Let me share my screen, right? And tell me whether my screen is visible. It should be visible now. Is it visible? Right. And you can see both the paper and the board, right? The screen. No, you can't see. Okay. One second. Right. I think now it's visible. Huh? Now it's visible, right? The split screen. Okay, now it's fine. Right. Now it's fine. Okay. Then let's start from the question one. Yes. Okay. Right. We'll start. Okay. First question. Right. First one. First one. The amplitude A of a damping oscillation of mass m is given by the following equation. And listen, since we are discussing a new paper this year, this is a seminar paper, that's a new paper, no? Right? I'll be explaining the background a little bit more compared to past papers as student at any level to understand whether you are fluent at this or average, or sometimes you might be kind of struggling with the subject still, right? You should be able to understand after the explanations. We'll explain a little bit more. Right. The amplitude of damping oscillation of mass m is given by the following equation. Right. A equals A naught E to the power, sorry, E minus AT of M, where T is time, the dimensions of A is. Right. We know indices are dimensionless, no? Right. Our logic is indices are dimensionless. Right. That's the logic behind this. Indices are dimensionless, right? Since indices are dimensionless, right? This term AT of M should not have any dimension. AT of M should not have any dimension. If we don't have a dimension, we usually represent it by 1, right? We represent it by 1. It should not have any dimension. Right, now dimension of A is asked, and time and mass are given, right? That is time. Then listen, if we need A, subject A from this, dimensions of T is T, dimensions of M is M, A, then A is given by cross multiply this, then MT minus 1. Right, it says there is MT minus 1. Then it should be L0, right? There is just MT minus 1. There's no L term here. L is 0, right? There's no L term here. L is 0. Then MT minus 1, L is 0 means answer 5. Answer 5. Right? Right, it's 5. Clear enough, right? Second one. A spectrometer, right? From our instrument, a spectrometer is a kind of a special instrument because for two reasons. One is this is the only instrument you have a main scale and a vernier scale calibrated in degrees, right? That is the one you have, the only scale you have in A levels calibrated in degrees, right? Degrees and minutes. So least count of this is in minutes, right? We know the standard one as a least count as 1 minute, right? So let's see about this one, how it is given, right? Then the other thing is that is not just a linear scale, that is not a linear scale, that is a circular scale, right? We have circular scales in some other instruments also, right? We have circular scales, but in other different ways. when it comes to sperometer, one linear scale and one circular scale, right? And sperometer, still one circular scale and one linear scale. But here, both are circular scales. Those are the two reasons that it is kind of like different and important to us. Spectrometer has a main scale division of 0.5. The vernier scale is set up by dividing 29 divisions of main scale into 30 equal parts, right? Then if you don't know, you can find the least count. Least count is one division of main scale over number of vernier scale divisions. One division of main scale is 0.5 degrees and number of vernier scale divisions 30, right? Then it gives 1 over 60 degrees. 1 over 60 degrees, no? 1 over 60 degrees means this is 1 minute. 1 over 60 degrees means 1 minute. So the least count of this one is 1 minute. 1 minute, just 1 minute, right? Then the figure shows how it set up to obtain a certain reading. What is the reading? So we know any reading is given by the addition of main scale reading plus vernier scale reading, right? Main scale reading plus vernier scale reading. Then main scale reading is the completed main scale before vernier 0, right? Vernier 0 starts here. Now 260, then this is 265, right? 65, then 65.5, then 66 is also completed and 66.5 is completed. Then 266.5 completed from main scale. Plus from vernier scale is written as coincided divisions into least count. Then coincided divisions here 1, 2, 3, 4, 5, 6, 7, right? Coincided divisions 7, coincided 7. Then 7 times least count 1 minute. Right, now answers are given in degrees and minutes. Then convert this to degrees and minutes. This is 266 degrees. And 0.5 minutes, 0.5 degrees means 30 minutes, right? 0.5 degrees means 30 minutes. Then altogether 30 and 7 is coming here, altogether 37 minutes, right? Then the final reading is 266 degrees, 37 minutes. 266 degrees, 37 minutes. Answer 3. Answer 3. Right? Hope clear enough. Hope it's clear enough. Right. Number 3. The displacement time graph of 5 objects are shown in the figure. Among them, the object that has an acceleration is, right? If there is a displacement time graph, right? Displacement time, right? There can be these kind of variables, these kind of variations, because this is a positively increasing gradient. Positively increasing means we know gradient of a VD, gradient of ST gives velocity. Now, if gradient increases, which means velocity increases, that is accelerating, right? Now, this is a positive increasing gradient, which means this shape is a possible acceleration. And other than that, this is a negatively increasing gradient. Right? Negative means opposite direction. Gradient increases means velocity increases. So that is still an acceleration. Then from this, we have 5. Right? That is not a big deal. Fourth one. As shown in the figure, 3 cubes ABC of each mass 2 kg are suspended by a light inextensible string passing over a smooth pulley. When the system is released in this way, the tension in the string between B and C approximately. Right. First of all, we need acceleration. To find acceleration, apply F equals ma for system along the string. Right. Always, if you have a common acceleration for the system given, apply it for the system at once along the string. Right. If there is a common acceleration. If there are different accelerations, then we have to approach separately. But if there is a common acceleration, you can do it for the system at once. Then F equals ma along the string for system. Along the string. F equals ma along the string. Right? Then along the string direction means something like this. Then along the string downwards, we have masses of B and C. One is 2 kilograms now. Then altogether 4, then 40. Opposite direction, weight of A, that is 20. 40 minus 20 equals total mass. Total mass is 2 plus 2 plus 2 is 6, then 6A. It is 20 equals 6A, which means A equals 10 over 3. A equals 10 over 3. Right? If A is known, now you can apply F equals ma for separately. Then again, downwards F equals ma for C. Applying for C is easy. Then for C, downward force is 20 minus tension T equals MA to A is 10 over 3. Then subject T equals 20 minus 20 over 3. Then that is 40 over 3. 40 over 3 is 13.3. 30 over 3 is 13.3. It's 3 again. It's 3 again. Right? It's 3 again. Okay. Got it? Again, not a big deal. Right? Understand and manage. 5. A transverse wave of frequency 60 Hz travels along a string at a speed 60 ms minus 1. Travels along a string at a speed 60 ms minus 1. What is the difference in radians between the amplitude of vibration of any 2 points of the string 25 centimeters apart? Right. To find the phase, that is called the phase angle. No? To find the phase, first we have to know lambda. Then apply V equals F lambda. V is 60. Right. F is also 60, which means lambda equals 1 meter. Lambda equals 1 meter. Now this wave goes like this. This wave goes like this. Sinusoidal. Waves are sinusoidal. Then lambda is 1 meter 100 centimeters. Like this. Now you asked about 2 points 25 centimeters apart. 25 centimeters apart means, right? Now it is somewhere here. 25, right? 25, 1/4 of this. So we know phase angle goes as 0, 90, 180, then 35 over 2, 270, 25. This is how it goes. And then at this point, the phase is, see, at this point, the phase is 90. At this point, the phase is 90. So phase is 90, it's 3. Right? Phase is 90. Right? If you ask about phase angle, right, the safest way is draw the wave. Right? Draw the wave. Once wave is drawn, right, easily we can see what's happening. Once the wave is drawn. Right. 6. An object of mass 2 kilograms is placed on a rough inclined plane with an angle of 30 to the horizontal. The coefficient of static friction between the object and the plane is 0.5. What is the minimum force that must be applied along the plane to prevent the object from sliding down? √3 equals 1.7. Right. So first we'll see what is the force that is done by created by the friction, because what we have to apply to balance it is, right, the balance of mg sin theta and friction, no? Because friction is doing this up to some extent. Right, let's see. Now 2 kg, which means 20. Then in this direction, along this direction, sine component 20 sine 30. 20 sine 30 is 10 newtons, no? Right? And along this direction, 20 cos 30. 20 cos 30 is 10 root 3. 10 root 3. Right? And the reaction is R, let's say, and I need to find friction. Right? Then at once we can get the limiting friction here. F equals mu R. Mu is given, right? Mu was 0.5. And R is 10 root 3. R is 10 root 3. Then this is 5 root 3. Root 3 is given as 0.7. Then 5 times, 1.7. 5 times 1.7. Which means 8.5, no? Right. 17 times 5 is 85, then 8.5. 8.5 newtons. Then friction here is 8.5. Right. See what's happening now? This force is 10 newtons. Downward force acting on the system is 10 newtons. And friction balances up to 8.5 newtons. Then still there is an unbalanced force of 1.5 newtons acting downwards. Right? If we externally balance that additional 1.5, right? If we externally balance that additional 1.5, the system will be at equilibrium. Then only this additional 1.5 should be given. Only this additional 1.5 should be given. Right? Because downward force is 10 newtons. Right? So without writing any further equations, get it from here. 10 newtons, whereas friction is responsible for 8.5. Then to balance the remaining 1.5, we can apply our external force. Right? Then there is 1.5. that is 1.5. Right? A friction question. Friction. 7. A ray of light travels from a vacuum into a medium with a refractive index of n. If its angle of incidence is twice the angle of refraction, what is the angle of incidence? Target. Right. A ray of light travels from vacuum into a medium with refractive index 1 over n. And if the angle of incidence is twice as the angle of refraction, which means I equals 2 or no? Angle of incidence is twice that of angle of refraction. I equals 2r. Then apply Snell's law. N1 sin I equals N2 sin R. N1, this travels from vacuum. Then 1 into 1 times 1 into 1 times sin I equals n times sin R. Right? Then sin I can be written as sin 2R. No? Sin 2R. This is n sin R. Right? So we know half angle expansions. Sin 2 theta equals 2 sin theta cos theta. Half angle expansions. Use this. Sin 2 theta equals 2 sin theta cos theta. Right? Then here, then sin 2r can be written as 2 sin r cos r equals n sin r. Right? Then sin r to sin r cancels. Right? We can first find r, then we can find I. Then r is given by right, cos r cos r is n over 2. Right? Cos r is n over 2. Then r equals cos inverse n over 2. No? R equals cos inverse n over 2. Right? What is asked? Angle of incidence. I equals 2r. Then I equals 2 times cos inverse n over 2. Right? A little bit tricky calculation, and it uses the half angle expansion as well. Right? It uses the half angle expansion as well. Right? Next. Question 8. 5 forces of magnitude 10 newtons each acting in 5 directions from a single point on the same plane. The same inclination exists between any two adjacent forces. What is the magnitude of the resultant of the system of forces? Right, if the same angle exists, right, we know this total angle is 360, no? Right? Now, if the same angle exists between 5, then 360 over 5. That is 72, right? 72. Then angle between any two forces is 72. Right? If angles are equal, all the forces are going to cancel each other. If angles are equal, right? So therefore, if angles are equal, if resultant is 0, nothing to do with the question. Resultant must be 0. Resultant must be 0 if angles are equal. Right? Always doesn't matter how many number of forces are acting. If angles are equal, always it becomes 0. Say you have just 2 forces, angles are like 180, 180. Say 3 forces, angles are like 120, 120, 120. Still equal. 4 forces, 90, 90, 90, 90, 0. 5 forces, 72. So you got 6 forces, right? 6 forces. Then 360 over 6 means 60. 60 and still 0. So likewise, doesn't matter how many number of forces you have with equal angles, always resultant becomes 0. Always resultant becomes 0. So that is 0. Right? 9. A fluid of density 1.2 10 to the power 3 kg minus 3 flows through a horizontal pipe of cross-sectional area 2.5 times 10 to the power minus 3. Its static pressure and total pressure are 6 kilopascals and 8 kilopascals respectively. If the fluid is an unviscous incompressible fluid, what is the flow rate of the fluid? Right. So we know flow rate of a fluid can be written as AV. Right. Flow rate, VOT. VOT is equivalent to AV. Right. Now in this VOT, this V refers to volume. Right. Right. Don't mess up. V here refers to volume flow rate. and V here refers to velocity. Right? Now, since areas are known, since cross-sectional areas are known, right? If we can find velocity, then we can easily get the AV, no? Right? Now, my target is finding velocity. Right? Now, by Bernoulli's theorem, to flow the liquid, pressure difference this has got is, right? Pressure difference this has got is here. Then from that pressure difference, since there's no change in gravitational potential energy per unit volume, half rho v squared, no change. Sorry, rho g is no change. Then only half rho v squared is playing the role here. Then this delta v equals half rho v squared. Delta v, pressure difference, 8 minus 6. That is in kilopascals, right? Kilopascals, 8 minus 6. Kilo means 10 to the power 3, right? Half rho is given. Rho is 1.2 10 to the power 3 v squared, right? Simplify. This is a fluid of density 1.2. Okay. Then this is 2 times 10 to the power 3 equals 2 times 10 to the power 3 equals half 1.2 10 to the power 3 v squared. 10 to the power 3 cancels, right? 10 to the power 3 cancels, and 1 second, density 1.2, density is correct, right? 6 and 8 kilopascals, then it is 2. It is 2. Then 2 times 2 is 4. 2 times 2 is 4. Is it 4 1.2 then? No, it cannot be. Give me 1 second. Whether there's a change in the numbers. So sometimes there can be kind of printing errors as well. I'm just checking another copy. Another copy means the right, I had another copy. Question number 9. Yeah, it is given as 8.4. Right, this is not 8 kilopascals, it is 8.4. It should be 8.4. Right? In the English medium one, I think the issue is there. In the single medium one, it's correct. Right? I checked with the single medium one, it's correct. Correct this as 8.4. Right? Correct this as 8.4 in the paper. Right? 8.4. Right? 8.4. Then we'll correct here. That should be 8.4. 8.4. That is given as a simplifiable manner. That's why I checked. Then this is 2.4. Right. Now 1.2 times 2. Now it's okay. Then 2 times 2. V squared equals 4. V equals 2. Right. V equals 2. If V equals 2, we need product AV. No? Then AV equals cross section is 2.5. 2.5 times 10 to the minus 3 into 2. That is 5 times 10 to the minus 3. 5 times 10 to the minus 3. So the answer is 2. Right? There had been a small typing error in that paper. Correct it as 8.4. That is not 8. 8.4. Right? Should be corrected as 8.4. Right? 10. A rod of Young's modulus 2 times 10 to the power 10 is subjected to a tensile strain of 0.06. Tensile strain, EOL. Now it says EOL. This one is 0.06, which means there is 0.06 over 100, 0.06%. Right? We can write this as 6 times 10 to the power minus 4. 6 times 10 to the power minus 4. What is the elastic potential energy stored in its unit volume? Elastic potential energy per unit volume. Elastic potential energy per unit volume is written as half times stress times strain. Half times stress times strain. Right? That is a proved equation in theory. That is a proved equation in theory. But if FOA is not given, then we can find another substitution. We know Young's modulus equation. FOA equals y times E over L. Then FOA can be replaced by y times E over L. Right? Then here, what comes after replacing it is half. Now FOA is this one, y times E over L, no? Then y times E over L squared comes, right? Then simplify. Half y is given 2 times 10 to the power 10, 2 times 10 to the power 10. Then E over L squared, E over L was here, see 6 times 10 to the power minus 4, then 6 times 10 to the power minus 4 squared, right? 6 times 10 to the power minus 4 squared, right? Then 2 to 2 cancels, 2 to 2 cancels. This is 3.6, no? The number 36, 3.6. Then there's only one answer with the number 3.6 or 36. So it is 1, right? It is 1. It is 1. Don't check the 10 to the powers and all that, because only number remains here in the simplification is 6 squared, 36. 6 squared, 36. Right? Only number remains there is 36. Only number remains there is 36. Right? 11. 11. A container of depth D is half filled with a liquid of refractive index mu1 and the other half is filled with a refractive index mu2. Right? Something like this. Right? Depth is depth D. Then D over 2 is filled with 1. The other D over 2 is filled with 1. Right? Like mu1 and mu2. Like this. Right? mu1 and mu2. When looking at the bottom of the container from above, the apparent depth is, right? If there are more than 2 media given, right? If there are more than 2 media given, easily you can write the total apparent displacement as the apparent displacement due to each medium, right? Apparent displacement due to each medium. We all know the equation of apparent displacement is D equals T times 1 minus N2 over N1, right? Where N2 is the observer's medium, N2 observer's medium, N1 is object's medium, right? D is apparent displacement, T is the thickness of the medium, right? Now we can find the total apparent displacement by the addition of these two, no? Then total apparent displacement equals, right? The addition. For first one, I'm writing this D over 2, 1 minus, then observer's medium is air because I is kept at air medium. Observer's medium is air. Then 1 minus mu 1, 1 over mu 1, plus second medium, thickness is D over 2, 1 minus 1 over mu 2. Right? Now from here, what we get is total apparent displacement. Right? What is asked is total apparent depth. Then total apparent depth is again total depth minus the apparent displacement, because apparent displacement is the displaced height. Right? Apparent displacement means this. If the image is somewhere here, right? This is what we call the apparent displacement. This is what we call the apparent displacement. The question is asking about apparent depth. This one, right? We can do some numbers and find it if you know D. Right? Now D can be written as D over 2 is common. Take it out. Then 1 minus 1 over mu 1 plus 1 minus 1 over mu 2. Right? Then this capital D is coming as D over 2. Right? Here 1 plus 1, 2. Minus is common, no? So we are taking out. Then 1 plus mu 1. Sorry, 1 over mu 1 plus 1 over mu 2. Right. Now we need apparent depth. Therefore, apparent depth is given by total height minus apparent displacement. Total height minus apparent displacement. Apparent displacement is this one. Then there is D over 2. Right? D over 2. 2 minus this part. 1 over mu 1 plus 1 over mu 2. Right? 1 over mu 1 plus 1 over mu 2. Right? Then a small simplification, right? Small simplification. D is common, take it out. Then here 1 remains, and here this half remains, right? 2 minus this part remains. What is simplification at the end? Right. Then D is out. Then 1 minus. If you multiply this with half, right? The brackets with half, then 1 minus half into 2 is minus 1, no? Right. Then plus means again half comes here, half. and this term remains. Right? See how this cancels off, this cancels off. Then which means final answer d over 2, what is simplification at the d over 2, and here 1 over mu1 plus 1 over mu2 remains. Right? d over 2, 1 over mu1 plus 1 over mu2. Right? d over 2, 1 over mu1 plus 1 over mu2, that is 4. That is 4. Right? It's 4. Right? That's a good calculation, huh? Kind of a good calculation. Right? I have to do something in the question. Do something in the question. Right? 12. And this is not the only way that you can try the question, right? Or else you can use the other equation of apparent depth and real depth as real depth of apparent depth equals n1 into. That is also fine. 12. A uniform circular rim of radius r and mass m as shown in the figure is rolling without slipping. Rolling without slipping on a horizontal plane with velocity v. What is the maximum height it can travel up to the rough inclined plane? Travel up the rough inclined plane. Right. A uniform circular rim of radius r rolling without slipping. Then I'm going to apply conservation of energy. Right. Total initial energy equals total final energy. Right. Initially, what it has is it has two motions since there is a rolling motion. Half mv squared plus half I omega squared is there. And finally, there is only mgh. There is only mgh. Right. What is the maximum height? Then we can find height from here. And that is a rim. A uniform circular rim. Rim is like a ring, no? Then moment of inertia, you have to know moment of inertia of a ring is mr squared. Then simplify. Half mv squared plus half I. Moment of inertia of a ring is mr squared. Then mr squared, omega squared. Omega is, what is the equation? Omega is VOR. Omega is VOR, V equals R omega. Then this is V squared over R squared equals mgh. Right? M is common, cancels. And here R squared cancels. Right? Half V squared plus half V squared. Half V squared plus half V squared is V squared. Then V squared equals GH. V equals root GH. V equals root GH. Sorry, what is asked? Height. Sorry, we need height. Height is V squared over G. Height is V squared over G. Then we need H. V squared over G. V squared over G. Right? Energy application. Right? 13. Right. What is the time taken for light to travel through a transparent medium? Light to travel through a transparent medium of thickness 4 millimeters made of a material with refractive index of 3. The speed of light in vacuum is okay. Then to find the time, we need the time first. Then n1 v1 equals, sorry, speed first. Then n1 v1 equals n2 v2. Find the speed. Then in vacuum, 1 times 3 to the power 8. And n2 is given as 3. Right? 3, no? Right, v2. Then 3 cancels. v2 comes as 1 times 10 to the power 8. Unit time is equals ut. Right? Then the thickness is 4 millimeters. 4 times 10 to the power minus 3. Right? Now u is 10 to the power 8 t. Right? So it should be, only number here is 4, no? Right? It should be something with 4. Don't check the answers further. Only number we got is 4. It is 2. 14 answers there, sorry. There are 2 answers with 4. Then simplify and see. Then 4 times 10 to the power minus 11. 8, 10, 3 again, minus 11. Okay, it's 2. Right? 14. Two capillary tubes A and B of equal lengths with radii R and R02 respectively are connected in parallel, and a viscous liquid is allowed to flow through them under same pressure difference. Right? If the flow rate through A is 8 times 10 to the power minus 3, what is the flow rate through the combination of tubes? Okay, now they are in a parallel combination, no? Connected in parallel. Okay, then this is how these two tubes are. Right, this is how these two tubes are. Right, two capillary tubes A and B, equal lengths with radii R and RO2. Right, let's say this is R and this is, right, and say this is R and RO2, right, R and RO2, right, parallel viscous fluid. Okay, then let's say volume flow rate through this one is Q1, volume flow rate through this one is Q2, and the total volume flow rate of the system as Q. Right, now we know from Poisson's equation, right, Q can be written as VOT, right, Q means VOT, yeah, VOT is phi delta V R to the power 4 over 8 theta L. Right, now remove the constants. Right, we don't need constants, so phi is a constant. Pressure difference, what about pressure difference? Under same pressure difference constant, right? 8 eta L all are constants, which means Q is proportional to R to the power 4. Right, apply this for these two scenarios given. Right, first scenario, 8 times 10 to the power minus 3, 8 times 10 to the power minus 3 flowed through A is, then that is proportional to R to the power 4. For next one, if that is Q, that is proportional to R over 2 to the power 4, R over 2 to the power 4. Right, divide these two, then 8 times 10 to the power minus 3 over Q equals R to the power 4 cancels, and this comes as a 16, then 2. This comes as 0.5 times 10 to the power minus 3, no? 0.5 times 10 to the power minus 3. Q is 0.5 times 10 to the power minus 3. Now, we know total Q is Q1 plus Q2. Right, Q1 was 8, Q2 is 0.5, then the total is 8.5. Total is 8.5, it's 2. Right, total is 8.5. Total is 8.5. Poisson's equation. Right, sorry, 15. Right, 15. The figure below shows the possible paths for a football that is thrown upwards from ground level. In the answers below, VU and T represents the vertical velocity. VU and T represents the vertical velocity, vertical velocity, horizontal velocity, and flying time respectively. Then letters in the brackets indicate the base characters respective to path. If air resistance is ignored, which of the following statements is correct? Okay, then you can clearly see their angles are different, and you can clearly see their ranges are different, right? Then get two equations for the angle, and the angle or height and the range, right? Then to find the range, first we need time, no? Then upwards, if we apply C equals UD plus half AD squared, I'm going to consider random projection as angle theta. Then S is 0. Upwards use sin theta T minus half GD squared, right? Then 1 T cancels. Subject T, it comes as 2U over G sin theta. Right? This is the time. Now, if you need 1 second. Right. If you need the horizontal range, then apply S equals UT. Then horizontal range is given by U cos theta. T is 2U sin theta over G. Then horizontal range is here 2U squared sin theta cos theta over G. Right? Now, for the ease of arguments, we know this. Right? For the ease of arguments, for the ease of arguments, we know 2 sin theta cos theta equals sin 2 theta. So this can be written as U squared sin 2 theta over G. Right? This is the horizontal range. Right? This is the horizontal range. Then about horizontal components, vertical components separately asked, right? Separately asked about vertical and horizontal components. Then first let's argue with the vertical velocity, right? First we'll argue with the vertical velocity. Now to argue on the vertical velocity, right? I need height, no? Height kya thagam? Then v squared equals u squared plus 2s upwards, right? Then v squared 0 at the topmost point, u squared sine squared theta minus 2gh, right? See what is coming for the height? Then 2gh equals u squared sine squared theta, h is u squared sine squared theta over 2g, right? Menna height h equals u squared sine squared theta over 2g, right? Now as v, what is given first as v? Vertical velocity, right? Vertical velocity. Now we know heights are given as same, right? Heights are given as same. Then about angles we know something. About angles we know, right? Easily argue ganna puluwan. Theta 1 is the greatest, right? Theta 1 is greater than theta 2, less than theta 3, right? Then it's still heights are equal. Right? See, then even though angles are different, heights are equal. Then if heights are equal, right? We are just asked about this u sine theta, right? Lazy, because only the vertical component is asked, right? Angle. Then if the vertical component is v, I can rewrite this as v squared over 2g. Then if h is same, v should be same. Now there are few answers with equal velocities, right? Keep it there. And horizontal velocity is given as, right? Before that we can argue on time. What about time? Times are here. See. Now we know u sine theta was same in both, right? U sine theta was same in both, which means u sine theta was same from the previous argument. If u sine theta was same, times must be same, no? If u sine theta was same, 2 and g are constants, times must be same, right? Then times are also same. Now I have decided on two things. And finally, to find the horizontal velocity, right? No need to apply the components, right? Very easy now. No need to apply the components. Then range is given by, if the horizontal component is u, ut. Times are also same. Then higher the range, higher the u. Higher the range, higher the u. Highest range is 3, then that must be u3 is the greatest. That's a good argument. Right? Always back up your thing with the equations. Right, back up your answers with equations. Right, 16. A trolley of mass 200 kg and length 5 meters is at rest on smooth horizontal rails, and a man of mass 50 kilograms is at one of the ends. He walks along the trolley to the other end. Then the distance walked by the man relative to ground is. Okay, so we can solve these type of questions using conservation of mass. Sorry, center of mass. So let's consider this as a common axis, and once this person walks, we know this goes backwards. Let's say the distance traveled backwards is x, right? Let's say, right? And here if I mark these forces, trolley of 200, then this is 200. G cancels, no? No need to write G. And this person 50, right? Then 50G. And at this point, the trolley's weight is here 200G, and person is here 50G, right? If center of mass remains unchanged, always force movements about the given axis is same. If center of mass remains unchanged, right? That is a main theory we discuss under center of mass. Then for the first scenario, what's the length? Length is given as 5 meters. Then one side is 2.5. Right, then first moment 200G, G cancels, no? Right? I'm not going to write G cancels. 200 into 2.5 plus 50 times 5. And the second scenario, 50 times x plus 200 times x plus 50. Right? 200 times x plus 2.5, x plus 2.5, x plus 2.5. Right, simplify this. Here 200 times 2.5 is there, and from here also 200 times 2.5 creates, it cancels, no? 200 times 2.5 creates, it cancels, then it cancels with this. Then here 50 times 5, 250 remains, and this side 50x plus here 200x remains. Then x equals 1 meter, which means distance traveled backwards by the trolley is 1 meter. Now from here to here, person has walked 5 meters, right? From here, person has walked 5 meters, and at the same time, trolley has traveled 1 meter backwards. Trolley has traveled 1 meter backwards. Trolley has traveled 1 meter backwards. Then displacement of person with respect to ground is 4 meters. Again, a little bit tricky question. Displacement of person with respect to ground, 4 meters. Right? Center of mass. Right? There are other ways of simplifying or doing these questions. Right? I use center of mass. I use center of mass theories. Right? And other than that, there are some other ways also. If you have done in a different manner, that's fine. 17. A light ray incident on an equilateral prism is shown in the figure. If its angle of incidence is 3/4 of the prism angle, okay, then that is an equilateral prism, no? Equilateral prism. Then prism angle is 60. 3/4 of the prism angle is 45, no? Right? 3/4 of the prism angle, 60 is 45. Then incident angle here is, right, what it says is it's 45. Then this is 45. And the angle of incidence is equal to the angle of emergence. What is the refractive index of the material of the prism? Angle of incidence equals angle of emergence means this is a symmetric diagram like this. That is symmetric diagram, right? Then angle of incidence equals angle of emergence, right? That is a symmetric diagram like this, right? And actually that is a minimum deviation. That is why diagram is being symmetric, right? That's why diagram is being symmetric. That's a minimum deviation, right? Now we know from prisms, if this is 60, this angle is also 60. This is also 60. Right? If these two angles are equal, listen, if these two angles are equal, this is a geometry. If these two angles are equal, these small angles are also equal. These small angles are also equal. If 45 and 45 are equal, right? Addition of these two should be equal to the external angle, no? Then one angle here becomes 30, 30 and 30. That's it. Now apply the Snell's. N1 sin I equals N2 sin R. N1 is 1 sin I sin 45. Right? N2 is what we need, and sin R sin 30. Right? Then 1 over root 2 equals N2, right? Half. Then root 2 cancels with this. Then it says N2 equals root 2. N2 equals root 2, it's 4. Right? N2 equals root 2. Right? Now, if you find the angles, right, there's nothing there. If you find the angles properly, angles take a geometry, that's geometry, right? If you struggle with the geometry, then there's something to think of. 18. Consider the following statements about inertia. Inertia is the reluctance of an object to change the state of motion. That is correct, no? That is correct. Then the force required to push an object on a smooth horizontal surface depends on the gravitational mass of the object. That does not depend on the gravitational mass, right? If there is on a horizontal surface, right, that is a smooth horizontal surface, which means no force is required at all, right? No force is required. If that was a rough plane, then friction is required. But if there is just a smooth plane, right, no force is required. Even for 0.0001 force it moves, right? That is almost zero. Then required force, that is strong. Weight එක දෙන්න ඕනේ නේද මේක move කරන්න. That is strong. Inertial mass is measured by the spring balance. Strong. Inertial mass means that is a mass contributes the moment of inertia. That is not measured by the spring balance. What is measured by the spring balance is the gravitational mass. What is measured by the spring balance is the gravitational mass. So C is also wrong. Then only That is a statement. Right. Then 19. A uniform body of hydrometer is uniformly calibrated from top to bottom as 0 to 10. When it floats in water, it sinks to level 0. It sinks to level 0. Right. Then let's consider volume of this part as V and area of this part as A. Right. Now, if volume and area are known, right, we know when it flows, U equals mg. No? When it floats, U equals mg. Now, initially, when it floats in water, U is V rho g. Now, V is V plus, right? This height is 10, no? 10a. V plus 10a. Water, rho w, g cancels m. Right? This is one of the equations. Then, to get a second equation, it says, and when immersed in a liquid of relative densities are given, then let's go with relative densities. We can do the entire question with relative densities instead of densities. If relative densities are given, then if relative density is given, then relative density of water is 1, no? Which means V plus 10A equals M. This is my equation 1. Right? Then for the next one, when immersed in a liquid of relative density 1.5, it's immersed to, and when immersed to sinks to 0. Oh, sorry. Am I wrong? When it floats in water, it sinks to level 0. Okay. And when it immerses in a liquid, it to 10. Okay. Alright. Then liquid. Then for liquid also, U equals mg. Then if there is 10, only V comes. Right? And rho is 1.5. Right? 1.5. G cancels equals m. Right? Here we have an answer for m. M equals 1.5 V. Right? Give it as 2. M equals 1.5 V. M equals 1.5 V. Right. Then since that is known, we can get something by combining these two. See, then V plus 10A equals M. No, that is 1.5. That is 1.5 V. What's the meaning? 10A equals 0.5 V. Right? Then V equals 20A. 0.5 means half, no? Another result, V equals 20A. Now, what is asked is the relative density of the liquid when it sinks to 5. Okay. Then for that liquid, apply again. U equals mg, right? V rho g. Now V is V plus 5a up to 5, no? We need relative density, say rho, right, equals m. Now, for V, we know we can write 20a instead. For V is 20a, no? Then this is altogether 25a, right? 25a, right? 25a rho equals m. For m, we can write m was 1.5 V. M was 1.5, 3 over 2 V, and V is 20a. Right? Simplify. A cancels. Then 5 times 4, 5 times 5. Right? Then this is 2 times 2. Then rho equals, it says 6 over 5. Then 1.2. Right? 1.2. Right? Now, as long as your substitutions and everything are correct, right? That's a normal question. Right? Hydrostatics hydrometer. Then next one, 20. A smooth wire connects 2 points. A smooth wire, right? A smooth wire, right? Something like this. A smooth wire connects 2 points A and B on a fixed vertical wheel of radius capital R. When a smooth bead attached to it's placed at B and released from rest. The time taken by it to reach B is okay. See, that's a good one. Now, if this center is here, right, we know if these two lines are connected, both are radii, right? Capital R, both are radii, right? Since that is equivalent to radii, right? If this is theta, this is also theta. Now for the ease of writing the distance here, if we construct a normal, right? See, one side becomes r cos theta. This becomes r cos theta. Then this is also r cos theta. Then total length here is r cos theta. And when this bead travels, we know gravitational acceleration acts vertically downwards. If gravitational acceleration is vertically downward, get the component acting along this side. Get the component. If this is theta, this is also theta, no? Then this is g cos theta. To find time, apply s equals ud plus, right? So likewise, easily approach the questions. S equals ud plus half a t squared. S is 2r cos theta, right? U0, then half g is g cos theta, t squared, right? Cos theta cancels, then it should be something which does not contain cos theta in the answer. So answer is 1, right? Because the only answer that does not contain cos theta is 1, right? If needed, simplify it. T squared d is coming as 4r over g, right? That's it. So it is 1, right? Finding angles, lengths. So, right? So those are, right, some things to do. Think of. 21. A person wearing a pair of glasses with the power of 2D must hold a book at least 40 centimeters away from his eyes to read clearly. The power of the lens he must wear to see clearly an object 25 centimeters away from his eyes. Right. A person wearing a pair of glasses with the power of 2D. Now, he is still wearing one with the power 2D, you know, with the power 2D, right? He is wearing one. A person wearing a pair of glasses with power of 2D must hold a book at least by 40 centimeters away. Right, now that image at 40 should be taken back to 25 again. Image at 40 should be taken back to 25 again. Right. I should read clearly. The power of the lens must, okay. Then let's do this way. Let's do this way. Now from this lens, even though he is wearing, now we have to take it from 40 to 25 now. Then let's find the power required for that thing. 1 over v minus 1 over u equals 1 over f, right? 1 over v is 1 over 40. 1 over u is 1 over 25 equals 1 over f, right? Equals 1 over f. Then this common denominator is going to be, this common denominator is going to be 200, no? 200, 4 times 5 and 25 times 8 equals 1 over f. This is 3 over 200 equals 1 over f, right? Which means now we need power. Power is 1 over f, right? Then power is 1 over f. 1 over f is 3 over 200. This thing into, to convert this to meters, right? Convert this to meters, then 100. Then 100, then here it says 1.5 diopters. Since that is a convex lens, right? This is actually minus. Make a minus now. This is a convex lens, and power is plus. Then it is plus 1.5d, right? Plus 1.5d. Now the thing is this. Listen, thing is this. He is already wearing plus 2 diopters, and additionally he need plus 1.5d. Then altogether he need 3.5. Then answer 3. Altogether he need 3.5. Right, answer 3. I applied only for the additional part, and then we can sum up. That is easier. Right. 22. Consider the following statements about a potentiometer circuit shown in the figure. Right. Even if E greater than E naught is an equilibrium length can be obtained. E equals E naught, no. Because if the E is greater than E naught, right, the potential difference across the potentiometer wire is less than the total potential difference in the below loop, in the sub-circuit, right? Always sub-circuit is going to balance to one of the parts of the balance length, one of the parts of the potentiometer wire, right? Then if this potential is greater than the total potential here, that is never going to balance. That is never going to balance. Right? One is wrong. Right? One is wrong. One is wrong. That is never going to balance. The internal resistance of E has no effect on the equilibrium length, just because no current flow through this, no current flow through this, no current flow through this at the equilibrium. So no impact from R. That is correct. If the value of R is increased, the equilibrium length also increases. If the value of R increases, what is R? This one. If the value of R increases, right, this is the impact. If the value of R increases, when R increases, VAB, potential difference across R increases, which means potential difference across potentiometer wire decreases. When potential difference across potentiometer wire decreases, K of potentiometer decreases because K of a potentiometer is given by, right, listen, K of a potentiometer is given by, K of potentiometer is given by VAB over LAB. When V decreases, K decreases. Then VAC equals KL for any length. If K decreases, L increases for a given potential. Then C is also correct. Then that is B and C. Right? Statements. Have to have a good understanding to do the statements, even though they are statements. Right? Have to have a very good understanding on potentiometer. Right. 4. A conductor wire bent into a circular arc of radius R as shown in the figure. Right. A bent conductor, no? Force on the bent conductor. If a bent conductor is given, always force is exerted to satisfy the gap only. May gap then if radius is R, R and R, this length is root 2R. This length is root 2R. Right? So we know equation is F equals BIL. BIL. Then B, I is given as I, L is the length of the gap root 2R. Right? Very simple. Very simple if you know these theories properly. Right? Very simple. Always in a bent conductor, force generates to satisfy the gap. Force generates to satisfy the gap. Force generates to satisfy the gap only. 24. 24. Right? 24. A wire of uniform cross-sectional area is stretched until its length is 4 times. Right? So we have a wire here, and then it is stretched until its length becomes 4 times. Then L and 4L. Something like this, no? Two scenarios. L and 4L. Its original length. Consider the following statements. Right. So we know still volumes are equal, no? Because I need to get an idea about their cross sections, say A1 and A2. We know, right? Even though it is stretched, volumes are equal. Then A1 times L equals A2 times 4L. L cancels. Right? One relationship is here. A1 equals 4A2. A1 equals 4A2. Right? We might have to use it somewhere if it is needed. First statement, the resistance of new wire is 4 times the resistance of the original wire. Right? Check it with the equation. Resistance of a wire is rho L over A. Resistance of a conductor wire is given by rho L over A. Then R equals rho L over A. Right? Here, rho is a constant. Right? Then apply here. For first one, let's say that is R. Then R is, right, rho L over A1. And for second one, let's say R dash, that is rho 4L over A2. Over A2. Over A2. We know A2 is A1 over 4. No? A2 is A1 over 4. Right? A2 is A1 over 4. Right, now, when you simplify this, it is rho L over A1 times 16. No? Right, now that's enough. Rho L over A1 is R. Then this is R. Then this becomes 16R. So the resistance becomes 16 times. Resistance increases to 16 times. A is strong. Resistance increases to 16 times. Resistance increases to 16 times, not 2 times, not 4 times. That is to 16 times. Right? Then part B, statement B, the resistance of the new wire is 16 times of the resistance of the original wire. That is correct. Right? That is correct. That is correct. Then see, if the same potential difference was applied to two ends of the wire before and after stretching, then the rate of heat generation from the wire increases 16 times after stretching with the same potential difference. No, we know heat dissipation is given by with the potential V squared dou R. No, this is V squared dou R. Even though potentials are same, now resistance are different. Resistance are different, so R are different. R are different. This is wrong. Answer is only B. Right? Only B. Only B. right? 25 is an easier one, right? 25, that's a rigid reflection of a wave pulse originating from a heavy string is reflected by a hard wall as shown in the figure. Which of the following diagrams correctly shows the position of the wave pulse after reflection? Right, there is a rigid reflection. In rigid reflection, what happens is, right, rigid means, right, wave is inverted, right, pulse is inverted, right. Then if the original pulse is like this, right, after the reflection, right, what happens is pulse returns back, pulse returns back, pulse returns back. Say these points are ABC for our is ABC. Now A comes first, pulse returns back, A comes first, but after inverting only like this. It is going to invert and it is coming back. It is coming back, but that is inverted. That is inverted, then it is 3, right? It is 3. Due to a smooth reflection, no inversion. For rigid reflection, due to rigid reflection, right, there is an inversion of 180. There's an inversion of 180. Right. Okay. We'll discuss the remaining 25 questions on another day. Right. We'll discuss the remaining 25 questions on another day. Now, first 25 are done, and we'll discuss the remaining 25 on another day. Any questions from these 25 questions we discussed? Any questions? Anything to clarify from these 25 questions we discussed so far? Anything? Or is it all clear? Is it clear enough? Anything to clarify from the questions we discussed? Is there anything to clarify from the questions we discussed? You can ask if anything, and if it is clear enough, say it's clear. All clear, right? So I'll be taking another day for the remaining 25 questions, right? And I'm planning to discuss part 2 of the support seminar as well, right? Structured essays and right, all parts we'll discuss, right? Then, right. Then, if there's no questions, right, we are good to wind up the session. If there's no questions, we are good to wind up the session. And as I have informed in the classes, you will be having the final electricity seminar, on electricity, right? Final seminar on electricity this Sunday, right? We'll have the final seminar on electricity this Sunday, right? 1 second. Okay, we'll have the final seminar on electricity this Sunday, right? And from there, all the practical things will also be over, right? Okay, then if no questions, we'll wind up, right? Practice those questions again and again, right? And you can practice the questions here in support seminar and again join the next discussion, right? Then stay safe these days, right? We are just 4 weeks from the exam. Stay safe and work hard, give your fullest, give your maximum and work hard, right? All right, then we'll stop for today, right? We'll meet with another S2AO. We'll see you in the class, right? Then good night and goodbye. See you.